Right now, a spacecraft the size of a small car is hurtling through interstellar space at 38,000 miles per hour, transmitting a signal so faint it takes 22 hours to reach us. And its power source has less than a decade of life left. Voyager 1 is the most distant human-made object in existence, currently more than 24 billion kilometers from Earth. Its nuclear batteries are decaying on a fixed, irreversible schedule, and NASA engineers have already begun switching off its science instruments one by one just to buy a few more years of contact. When the last instrument goes dark, projected sometime around 2025 to 2030, humanity will lose its only first-hand messenger from interstellar space. This is the story of that countdown, what Voyager has already told us, and what we will never know once it goes silent forever. Distance is the first thing that breaks your brain when you try to understand Voyager 1. As of 2024, it sits approximately 24.3 billion kilometers from the Sun, more than 162 astronomical units. Light itself, the fastest thing in the universe at 292 kilometers per second, takes over 22 hours to make that one-way trip. When you send a command to Voyager, you wait 44 hours for a round-trip response. That delay isn't a technical limitation. It is physics, absolute and unyielding. No spacecraft, no signal. Nothing travels faster than light. The Voyager team essentially writes letters to a traveler who won't receive them for nearly a day. And those letters are being sent to a machine that launched in 1977 on hardware designed in the early 1970s, technology older than the personal computer. Voyager 1 has no solar panels. At its distance, sunlight is 900 times weaker than at Earth. The panels would be useless. Instead, the spacecraft runs on 3 radioisotope thermoelectric generators, or RTGs, loaded with plutonium-238. These devices work by converting the heat from radioactive decay directly into electricity. When Voyager launched in September 1977, the RTGs produced approximately 470 watts of electrical power. But plutonium-238 has a half-life of 87.7 years, meaning its heat output drops steadily and permanently, roughly 4 watts per year. By 2024, the RTGs generate only about 249 watts. That's less power than 3 standard incandescent light bulbs. Every year, the margin shrinks. Engineers can't recharge them, can't repair them, can't replace them. The decay curve is a countdown written in nuclear physics, and it has no pause button. Because power is finite and shrinking, NASA's Voyager team has spent years making brutal triage decisions. Since 2019, engineers have progressively shut down heaters on instruments and thrusters to redirect watts to the systems that matter most. In 2023, Voyager 1 experienced a critical anomaly. Its flight data system computer began sending garbled telemetry, and for 5 months, the science and engineering data streams were corrupted. Engineers diagnosed the fault across a 45-hour round-trip communication delay, tracked it to a single corrupted chip in the FDS memory, and executed a software patch, essentially performing surgery on a 46-year-old computer from 24 billion kilometers away. The fix worked, but it was a warning. The spacecraft's systems are aging faster now. Each workaround costs time and power. Currently, Voyager 1 operates 4 active science instruments, but that number is expected to fall to 0 well before 2030. Despite its imminent silence, Voyager 1 has already earned its place as one of the most scientifically productive missions in history. It made its closest approach to Jupiter in March 1979, discovering active volcanic eruptions on the moon Io, the first time active volcanism was confirmed anywhere beyond Earth. At Saturn in November 1980, it revealed the intricate structure of the ring system and made close observations of Titan's thick nitrogen atmosphere. Then, on August 25, 2012, Voyager 1 became the first human-made object to cross the heliopause. the boundary where the sun's solar wind gives way to interstellar plasma, entering true interstellar space. The plasma density measurements it returned confirmed a sharp transition, resolving decades of scientific debate about the shape and scale of our heliosphere. These are facts we didn't know before Voyager. We could not have learned them any other way. On February 14, 1990, as Voyager 1 was 6.4 billion kilometers from Earth, mission scientists commanded it to turn its camera back toward home for one final portrait. The resulting image, conceived by Carl Sagan, shows Earth as a pale blue dot, a mote of dust suspended in a sunbeam, occupying less than 1 pixel of the frame. Sagan wrote, "On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." That image has become one of the most iconic photographs in history, and one of the most profound philosophical statements ever made possible by technology. The cameras were shut down immediately after to conserve power, a resource that even then, in 1990, was already precious. Earth's portrait cost Voyager watts it could never recover. The team decided it was worth it. NASA's current projections place Voyager 1's last functioning science instrument going offline somewhere between 2025 and 2030, depending on how engineers manage the remaining power budget. After the science instruments shut down, the spacecraft's transmitter may continue sending a carrier signal, a faint beacon with no data attached, for a brief additional period. But once power drops below the threshold to drive the transmitter, roughly 8 watts, that signal vanishes too. Voyager will then become a silent artifact, continuing its journey at 61,000 kilometers per hour forever. It will reach the Oort cloud in roughly 300 years. In about 40,000 years, it will make a close pass of the star Gliese 445, located 17.6 light-years away in the constellation Camelopardalis. No human alive today, and no human civilization we can currently imagine, will be there to witness it. No other spacecraft has ever reached interstellar space and reported back. Voyager 2 crossed the heliopause in November 2018 and also has fewer than 10 years of power remaining. When both go silent, humanity will have no direct sensor in interstellar space for the foreseeable future. No replacement mission has been fully funded or launched. The next interstellar probe concept, the Interstellar Probe Study, commissioned by NASA, targets a launch no earlier than the late 2030s and would take decades more to reach the heliopause. There will be a gap. During that gap, questions about the true shape of the heliosphere, the density of interstellar dust, and the particle environment beyond our solar system will go unanswered by direct measurement. Voyager 1 isn't just dying. It's leaving behind a silence that no instrument on Earth can fill. What it knew, only it knew, and it learned it for us.